Welcome to part 3 of Competency 2. In this video, we will work with the nth root of complex numbers in polar form, of course, using our TI-84. Number 1. What is the simplest polar form of 4 times cosine 27 plus I sine 27 times 13 cosine 100 plus I sine 100? Okay, as you see, we have two polar forms instead of rectangular of complex situations. Okay, here is the basic rule. If you see multiplication between the two, yes, your first instinct to multiply 4 times 13 is correct. So obviously we are not adding those together, but let me explain why they have this incorrect item here is because of this. You are multiplying the two together. That means that these, let's call them coefficients, the leading terms out here in the front, the 4 and the 13. We multiply those, yes. So that is, and I'll just do it real quick, always verify on your calculator. Don't trust yourself when you're testing. Testing is stressful. Use your calculator. Okay, so that eliminates A and B. Now here's the rule. You are multiplying. You multiply those numbers that are on the outside. Now it may not be precisely this particular form, and this will come up later, but for this video, this is the form that we have. Yes, you multiply the two on the outside, but the angles are added. That's why they try to trick you by saying 4 plus 13. You multiply the outer and you add the inner. Okay, and you can think of some rules in other areas of mathematics where there's multiplication and you add, and then if there's division, you subtract. Okay, so that means that we need to take 27 and 100, add them together, and you do it for both, not just one. So that eliminates D, therefore C is our option. Okay, so let's look at number 2. What is the simplest form of 44 cosine 250 plus I sine 250 divided by 8 cosine 170 plus I sine 170? Okay, as I just said, you will divide because of the division. You divide the outside, but with division is subtraction. Okay, thus we need to take 44 and divide it by 8. Well, I have a sneaking suspicion that it's 5.5 because all of these are 5.5. So let's see. 4, oh no, it's 44. Sorry, clear. 44 divided by the 8. And there you go, 5.5. All right, well, they're trying to suck us in. Okay, now one huge clue that's going on with A and B again. Last one, it was also A and B that were very obvious. These are different, and that would not be the case. Okay, so we're going to have to mark those out. All right, and there was a subtraction here with B. Okay, now let's look at what's really needs to happen here. We are going to subtract 170 from 250. So we're subtracting these two for each angle. They should be the same. Okay, so 250 minus 170. Always pop in the calculator. Okay, so we look at C and D. I see 80, 80, 80, 80. What is different? Well, look at option D. It has the wrong form. So don't, let your eyes get sucked in. And again, it's option C. Yeah, I've missed that I before in the wrong place, which the form that we are discussing here with I sine, There are other mathematics where that I will move around a little, but in this case, it will not, and we will have this form. Okay. End of that one. We have verified. Okay. That D was also the wrong form. Okay. Just be wary. Make sure you read and look at every single thing. Okay. All right. Now, let's go up here, 2, 3, and 4. Okay. What is the simplest form of, okay. Oh, let's see here. We have got 3 cosine 40 plus I sine 40, but it is exponential. So you take that 3 and give it the exponent of 6. The outside item, which is your R, remember this is your R item. Oops. Let's get rid of it. Okay, trying to highlight. All right. Your R is going to take on the operation. If you haven't noticed, that's the theme. Okay. So you take your R and treat it like you would a normal, just a regular operation. There are no other things to remember with that. Just tell yourself that and you'll be in good shape. Okay, so I've got my R and it's going to be to the 6th power. Obviously, A and B are not options. Okay. Now, we need to deal with our degrees are 40 degrees. Well, this is just not true. Okay. They made it super obvious, but let me explain to you what's going on. Yes, let's take 3 to 3, carry it up to the 6. Verify that it's 729. That checks. So if we have to the exponential, r's to the exponential, whatever that exponential is, we take our degree and 40, and we multiply. And that is 240. 40 times 6 is 240. So D is the correct option. What you need to see is the connection that if we have our R to an exponent, we need to multiply to the degree. Okay. Now let's look at number 4. What is the simplest polar form of, okay, 3 minus 2I to the 6? All right. Well, in this case, we need to figure out what is R and what is theta. What is the degree that we are initially working with? Well, we know how to do that. Our calculator will tell us. So go over to math, arrow over to complex, and let's do our number 5 for our R. We need our R first. So press number 5. Now put in our given, this part. That's going to get us our R. 3 minus 2, second I, push enter. Okay. Well, let's take that. Now that's just our R. We need to take the R and put it to the 6th power. Okay, remember R goes to the 6, whatever power we're given. Okay, so let's go carry it up 6, and now we're given the value that we need. And again, it's not 3 times 6. That's what they're trying to do here with B and C. They're just trying to trip you up before you begin. So now we're left with A and D. Okay, so we need to figure out what the angle is. Well, we know how to do that. Our calculator does. So say math, arrow over to complex. Now we need number 4. And we type in 3 minus 2, second I, close, parentheses, enter. Okay. Now, remember, if there's a negative, what do? We need to say 360. I like to do it this way. Push a plus, go up. Now, listen, you need to grab this. Don't just say 360 minus 33, because notice that our 33.69, there's rounding involved. So in order to get past worrying about the rounding, just capture it, push enter, bring it down. Now, our calculator knows to just subtract that. So push enter. And now we can see that we round easily to 326. Okay, and we have an option, and that would be D. Okay, notice I let all the calculator do all the work. However, I needed to know the rules. So you will need to write down some rules for yourself. One, how do I get my R? How do I get my theta, my degree? Then, how do I manipulate R? Well, you do whatever it says. If it says multiply, multiply. If it says divide, divide. If it's exponential power, to the power, okay? And then you need to connect. What do I do with my degree in each situation? Okay, do I subtract the degrees? Do I add the degrees? Do I multiply the degrees? When do I do whatever it is? Okay, all right, now let's move on to number 5. Okay, number 5. What are the 3 cube roots of 10 cosine 160 plus I sine 160? All right. The first thing that you need to do is look at your equation. You really need to study this equation or this formula and know how to use it. Okay, if you don't, go and research it. But the first thing that I had said prior still applies. This, whatever is said, which is cube, we want a cube root. So our n equals 3. So this 10 out here in front are R. Whatever action is said, you must apply it to the 10. Okay? Now, that eliminates B and D. They're gone. Okay? We need to apply it. Now, the next thing is we have a degree of measure. Okay? So what we need to do with that degree of measure is divide it. So this has got to be divided by, when we say cubed, that would be 3, right? Because you would have like to the cube root or to the cube power, whatever. So that means divide by 3. This n is 3. Okay, you just do that first, all right? Okay, so 165, divide that by whatever your n is, which is 3 right now. So that's 55. So you know the first item should be a degree of 55. All right, well, both of those have 55. That's interesting. We'll see that K right there. That K element, and I'm noticing the pattern for both of these options for A and C. Let me highlight. These are the ones that are different. So we need to focus on that fact. And we also know that our K, if we look at K, it looks like they're doing 0, 1, and 2. Okay? Because 55 would be added to 0. Okay? If you think about that, if K is 0, then this part added would be 0, which would leave us 55. Okay. So what we need to do is check out these angles, 103 and 295. Okay, so this is what you do. You say 305, subtract the 55, okay? Because that's, here, let me get a highlighter. That's this part right here for both of those, all right? Okay, so let's push enter. So that leaves us 360. That doesn't make sense. Well, let's go ahead and follow through. Well, 360. Well, look at your K. That's supposed to be equal to 360 times 2 divided by n. And it's supposed to end up being 360. I'm not going to buy that. Let's go through the process here. Let's do what, here, let me change colors. Let's do what it says. Okay, I've subtracted out 55. So watch this. 360 times 2 Okay, I'm going to go ahead and push enter. Now I'm going to divide it by, what did we have? We had 3. That's would equal 240. That doesn't make sense. Let's try C and see what happens over here. That is 290 minus our original 55. Oh, look at that. It's 240. Okay, so obviously we've eliminated A, and C is the option that we need. Okay, because think about it, what I did. I eliminated the 55 degrees because that's what's highlighted on each of our parts for our degree. And then I focused on, well, we need it, what do we need it to be? Well, you take 360 times the 2, okay, and then divide by n. Now, there's more to this nth root formula. If you aren't familiar with it, please go make yourself familiar with it. Okay, all right, let's move to number 6. This is a little different, but our calculator is really going to help out. It says, what are the 5 fifth roots of, okay, 2 square root of 3 plus 2i. Okay, well, let's take a look at that. We can get the r and the n. But first, we need to know what r is. Okay, so let's put this in the calculator. All right, so math, arrow over to complex. And to get r, we need number 5. And let's just type this in. 2 second square root 3. Remember, you got to arrow over to get out of the square root. Now we have plus, oops, we'll see, 2 second and the I. Right now, let's push enter. And it gives us 4. So our R is 4. And 4 needs to, we are looking at the 5th root. Well, we're being told that that is going to be a radical with 5. So that's A and D. So this is what we need right here and right here. So that eliminates this one and this one. See, for B and C, they just said 4 times 5. That's obviously not what we're doing. We need it underneath that radical with a root of 5. Okay, so we've done that. And now we need to deal with the degrees. Well, what did I tell you? The first thing you do, well, first we need a degree, and then we get a degree. Well, then we need to divide it. But we don't even know what the degree is. But I bet this TI-84 will tell us what that degree is. So let's say math, arrow over to complex. Remember, angles are number 4. Now let's pop that in. 2 second radical, put a 3, arrow over. And now we need plus 2i, plus 2 second I. Okay, I like to, my I didn't come up. Oh, let me press that again. I'm going to type over it, second I. Ah, there it is. Okay, now close my parentheses, push enter, and it says 30 degrees. That is the initial degree measure out of our formula. So what did I tell you? The first thing we need to do with the degree is divide it by whatever our root is. Well, we have a 5. Okay, so 30 divided by 5 gives us 6. Who says 6? Who's the taker on 6? Well, the only one of these that gives us that is D. Okay, and then we can go down and verify all of the other degrees, each of these. So what do? We take 76, just to satisfy yourself, and subtract out the original 6. Okay, so 76 is what we need. Now watch this. Let's do this. We need 360 times. Now, what do we multiply by? Now, this is one thing. If you haven't noticed, it's almost like modulus. We start with 0, then 1, then 2, then 3, then 4. Those are your K values, if you notice that. If it's to the third, you have 0, 1, 2. If it's to the fourth, the radical, the cube, is the fourth, then it'll be 0, 1, 2, 3. Now, to the fifth, 0, 1, 2, 3, 4. So here, this will be times, no, this one won't. It'll be the other way around. It looks like it's going up. I did it backwards. Well, and that's something that we have to notice. Okay, if it's 6, that means it was plus 0. So that's 6. So if that one, here, let me change colors. If this one is 0, then this would be your K. This will be your K values. My K. Each of these. If I'm looking at it correctly instead of backwards. Okay, there we go. All right. Much better. Okay, so that means it would be 360 times 1. So I'm going to go ahead and type it in. I mean, not that I need to. Okay. But that has to be now divide by 5. And that's 72, which is the value that we had. 76 minus the 6, the initial degree measure, gives us a 72. So now you can go and verify the others, but they would be correct. So D is our option. Okay, let's move to number 7. Okay, number 7. What are the 4 fourth roots of 12? Okay, so we know. Okay, this is kind of depending on your knowledge of complex numbers. 12 can be considered complex if we say this: 12 plus 0 pi. Okay? That being said, it should be quite obvious that the value of r is 12. Okay? But we can pop it in our calculator and show this. All right? So we need to go to math, over to, remember it's number 5. And if I say 12 plus 0, second I, 12. So it's 12. Okay. And the first thing we know is that R should be under the radical with 4 as the root. Well, that leaves us, let me scoot up a little. That leaves us A and D. So we eliminate B and C. All right, that's good. Now, what is our angle measure? Let's go pop it in and take a look. So math, go over, number 4 is what we want. And let's just put in 12, but I'm going to go ahead and put the 0 is 0, but I'll put it in, okay? Plus 0, second I, close. Just so happens it's 0. There is no angle measure. This thing is flat, okay? All right, whatever. So that tells us our initial angle should be 0. Well, I only see that on option A. I don't see that on option D. Because if we use our given formula, remember for our angle measure, we need to focus on theta divided by n plus, okay, they're both divided by n, but 360 times the k. Okay, well, our initial theta is 0, and k will have to be 0. Remember, this will be 0, 1, 2, 3. That's going to equal each of our k's, right? So 0 plus 0 is 0. And we don't have that here with any of them. Well, down on D, what they did is they just left it at 360. Well, that doesn't make sense given our formula. I guess that the point of this is to test your knowledge of the formula itself. So D is not it. Our only valid option is A. All right, that is the last question in this video. And again, gonna have to say thank you guys for liking us, sharing us, and definitely to you guys that have subscribed. You're the best. Happy testing, everybody.